Welcome to BCMSN Lab number 2. In this lab, we are going to configure a multi-layer switch to perform routing, to make a forwarding decision based on layer 3 IP address information, just like a router does. And we have a couple of different approaches that we can select from when we want our multi-layer switch to actually do routing. One approach is to create a virtual SVI, a switch virtual interface. You might recall from BCMSN Lab number 1, we created VLANs and assigned ports to those VLANs. Let's say that we have a VLAN created on our multi-layer switch, and we have various ports assigned to that VLAN. If we want those ports to be able to route to a different VLAN, there has to be a layer 3 IP address that is going to represent that VLAN. That's where an SVI, a switch virtual interface, can help us out. The SVI represents this collection of switch ports as a single interface. And in this single virtual interface, we can assign an IP address. Another approach is to take a layer 2 switch port and convert it into a layer 3 routed port. By default, when our multi-layer switch, specifically we are dealing with a Catalyst 3550 in this lab, when this switch comes up, all of the interfaces are acting as layer 2 switch ports. We can go in and tell one of these interfaces not to act like a switch port, and it will start acting like a routed port. We can assign an IP address to that now layer 3 routed port. And on our 3550, by default, IP routing is not enabled. We will need to globally enable IP routing and configure a routing protocol. We are going to use EIGRP. And if you would like a refresher of the EIGRP commands we're going to use, you may want to go check out BSCI Lab number 1, where we go through an EIGRP configuration. Once we have EIGRP set up, and we have our SVI created, and we have our layer 3 routed port configured, we are then going to verify inter-VLAN routing. Can we route from one subnet to another subnet? Here's the topology we're going to be working with. Notice our switch, SW1. That is a Cisco Catalyst 3550. And prior to our configuration, we have already assigned interface gigabit 0/1 to belong to VLAN 10. And we already have the EIGRP routing protocol configured on routers R1 and R2. What we want to do first of all is to create an SVI, a switch virtual interface, and assign an IP address to that SVI. We are going to create a switch virtual interface for VLAN 10. And once we're in interface configuration mode for VLAN 10, we are going to assign an IP address of 10.2.2.1 with a 24-bit subnet mask. That's one approach that we could use to configure routing on our multi-layer switch, but in this lab we want to show you another approach as well. We want to show you how to take a layer 2 switch port and convert it into a layer 3 routed port. That's what we're going to do to interface gigabit 0/2. We are going to make it a layer 3 routed port and assign an IP address of 172.16.0.1 with a 24-bit subnet mask. We will also configure EIGRP. R1 and R2, they are already configured for EIGRP, so we're going to form EIGRP neighborships with these routers. And as a final test, to make sure that we are indeed routing through our multi-layer switch, we're going to go over to the PC and see if we can ping the loopback interface on router R1, IP address 10.1.1.1. Let's take a look at the multi-layer switch syntax that we're going to be using. First of all, we are going to create an SVI. The way we do that is we say interface VLAN and give the number of a VLAN that we have already created. We have already created VLAN 10, so we are going to say interface VLAN 10. This takes us into interface configuration mode for this switch virtual interface. It is from here where we can assign an IP address to that SVI. The other approach to routing that we are going to demonstrate is how to take a layer 2 switch port and convert it into a layer 3 routed port. The way we're going to do that is to go into interface configuration mode for that layer 2 switch port and say no switch port. That converts it into a layer 3 routed port. And something else that we need to be aware of on this Catalyst 3550, by default, IP routing is not enabled, so we will not be allowed to go into router configuration mode for EIGRP until we first say in global configuration mode IP routing. That is going to enable the IP routing process on this multi-layer switch. Let's now go out to switch SW1 and configure inter-VLAN routing. The first thing we want to do is to configure an SVI, a switch virtual interface, on SW1. Let's go into global configuration mode and say interface VLAN 10. We already have a VLAN 10 created. Now we have entered interface configuration mode for that VLAN. From here we can assign an IP address. We can say IP address 10.2.2.1 with a 24-bit subnet mask. And we do not have to do a no shutdown. When we create this virtual SVI interface, it is already up by default. And we see that on screen. It says that VLAN 10 has changed to the up state. Next, let's go into interface gigabit 0/2. We want to take this layer 2 switch port and convert it into a layer 3 routed port. We do that with the command no switch port. Now that we have converted this into a layer 3 routed port, we can assign an IP address. Let's say IP address 172.16.0.1. Again, we're using a 24-bit subnet mask. And like an SVI, after we create this layer 3 routed port, we do not have to do a no shutdown. It also is in the up state as we see on screen. Something that's interesting about this multi-layer switch, by default, IP routing is not enabled. We need to globally enable IP routing with the command IP routing. This allows us to go into router configuration mode. And the routing protocol that the routers on this network are already running is EIGRP. Let's enter router EIGRP 1. We want to turn off auto summarization with the no auto summary command, and we want to be advertising for networks 172.16.0.0 with a 24-bit wildcard mask, and network 10.2.2.0, again with a 24-bit wildcard mask. At this point, we have configured this multi-layer switch with an SVI as well as a layer 3 routed port. We should now have formed EIGRP neighborships. Let's verify that. Let's do a show IP EIGRP neighbor. And yes, indeed, we have. Out of interface VLAN 10, this SVI interface, we have formed a neighborship with 10.2.2.2, and out of our layer 3 routed interface, gigabit 0/2, we have formed a neighborship with 172.16.0.2. Let's now see what IP routes this multi-layer switch has learned. Let's do a show IP route. And this is interesting. We now see the loopback interface attached to R1. We also see the network living on the far side of router R2. This is where the PC is located in our topology. To make sure that we are now indeed routing through this multi-layer switch, let's go over to that PC and see if we can ping the loopback interface on router R1. Let's go over to a PC window, and let's do a ping to 10.1.1.1. And we are routing through this multi-layer switch. This PC is passing through router R2, passing through the multi-layer switch, passing through router R1, and then we are getting this ping response from the loopback 0 interface on router R1. And as a best practice, what we like to do on the routers as well as our switches, we like to save our running configuration. We're going to say copy running-config to startup-config. This is the best practice in the exam environment as well as in the real world. Let's now review where we have been in this lab. In BCMSN lab number 2, we enabled routing on our multi-layer switch. Specifically, we went in and for an existing VLAN created an SVI, a switch virtual interface. This SVI represents the ports that belong to that VLAN, and we can assign an IP address to this virtual interface. That's one approach to doing routing on a multi-layer switch. Another approach that we demonstrated was how to take a layer 2 switch port and convert it into a layer 3 routed port. We did that on interface gigabit 0/1. We turned on IP routing globally, and we enabled the EIGRP routing protocol. We had already configured EIGRP on the neighboring routers, so we formed EIGRP neighborships, and we verified that we had formed those neighborships. We verified that we had learned routes via EIGRP, and then as a final test, we went to a PC and we did a ping to the loopback interface on router R1, and that ping response was successful. And we reminded you again that for the real world as well as in the exam environment, it is a best practice once we complete our configuration to copy that configuration, the running configuration, to the startup configuration.